Hey everyone, and welcome back to my channel. If you can't tell from my voice, I'm a little bit sick at the moment. I think I just have a fairly normal cold, but I'm waiting for a test result to find out more. I'll be posting updates on my Instagram if it is anything more sinister, so if you want to follow me there. But I did have definitely a very different video planned for today, but obviously as you can hear, I don't sound super good, so I'm going to leave that for another day. And instead I'm going to be sharing with you a presentation that I recently gave at a conference called the International Conference of Case-Based Reasoning, all about my research into trying to provide explainable injury predictions and recommendations to marathon runners using the type of data that is tracked by wearable sensors like Fitbits and Garmin's and things like that. So without further ado, I'm going to show you that presentation. And if you're interested to know how I made this presentation, my previous video has all of the important details about how I made that presentation in Canva, but I hope that you enjoy this PhD student presentation and learning a bit more about my research.
Hi everyone, my name is Ciara and I'm going to be presenting the paper A Case-Based Reasoning Approach to Predicting and Explaining Running-Related Injuries. The team that worked on this alongside myself were UCD professors Brian Caulfield, Angus Lawler and Barry Smith. So the context of this work is marathon running. And for anybody that doesn't know, the marathon is a 42.2 kilometer event run on road, track or cross country, and it typically requires 12 to 16 weeks of very intensive training. Running is one of the most popular forms of personal exercise, and in recent years there's been a really big increase in the number of people participating in marathons. So we had 1.3 million people participating in marathons in 2018 alone. However, running is quite taxing on the body. It's estimated that one stride is equivalent to 2.5 times our body weight hitting the ground. So naturally, that means that there are a lot of injuries associated with running. Around 50% of regular runners get injured every year. Around 17% of people who signed up for marathons don't complete the race. Which could be due to injuries that have been sustained throughout training or perhaps injuries that might occur on race day. 45% of runners don't know exactly what preventative measures to take or don't take any actions towards injury prevention. And a lot of the time, the reason for that is because they haven't yet experienced a running-related injury and so don't necessarily feel like they need to do any preventative measures. So because running-related injuries are so common, there has been a lot of research done to really understand what could be some of the potential risk factors for running-related injuries and if there's any way to avoid these. So in the sports science research, there's been a number of things that have been proposed as potential risk factors. One of those being physiological variables related to running gait. So that could be how the foot is placed as it hit the ground, the hip motion and things like that. However, there hasn't necessarily been a definitive answer found in the physiological variables. There's also been evidence to suggest that training load could be a factor. So it could be overuse injuries due to higher training volumes and intensities or increasing the load too quickly, or it could be underuse injuries from runners who are not building up their training enough, and that can lead to injury. Experience of running is also commonly thought to be a problem, and running-related injuries are more common among novice runners, but they do affect all different types of runners. And another thing that has been shown is, or has been suggested, has been personality. So it was thought that being a type A personality could be linked to injury. However, that has been found to not be necessarily a reliable factor for injury. So with all of these, there have been some evidence, but not very strong evidence. And the only real reliable risk factor that has been shown was having a previous history of injuries. And even if a previous injury was, let's say, an ankle injury, that still made you more likely to be injured in a different part of your body at a future time. So there are a number of challenges for studying running-related injuries in the current sports science research. So one issue is that there are a lot of the time small cohorts. So studies are often only tens or hundreds of participants, and it's hard to guarantee that there is really a representative number in those small groups, given how many people do participate in marathons. Another issue is that often these studies are done with elite runners, so it's not necessarily as applicable to the recreational runners who do comprise most of the people who are participating in marathons. Often there is controlled environments, either a lab setting or some restrictions on training. So then it's not necessarily true that it will translate to the real world because it is a lot noisier. And lastly, relying on recall. So a lot of studies are survey-based, which means the runners need to be able to accurately look back at previous events and remember those and be able to present those in the survey, which isn't always the easiest thing to do. So the main contributions thus of our work is to use case-based reasoning with a large cohort of recreational runners, and we'll be using their raw training data with absolutely no restrictions placed on their training. With that, we're going to provide injury risk predictions, which at the moment, there aren't really any resources available for marathon runners to understand what their current injury risk might be. And we're also going to be providing with that some counterfactual explanations to understand how their current training load is giving an insight into why they might be predicted at risk of sustaining an injury and what they might be able to do to ward off the injuries and hopefully reduce their risk score. So moving on to the methodology. So this is the type of thing that we're trying to build. So having some way of understanding your risk score, how it ties in with other runners, and how that risk score is correlated with injury. So how likely it is that you'd get injury given that this is your risk score, and a suggestion of what might be possible to reduce that score. So the type of data that we have is raw training session data obtained through a data sharing agreement with Strava. We have training sessions for 5,000 runners in the 16-week lead up to a marathon, which is provided by Strava. And here you can see how that typically looks. So we have every 100 meters, we have the runner's distance, the time, the elevation, and then these can be converted into 100-meter pacing profiles, which are in minutes per kilometer. And once we add in the elevation, these can also be turned into grade adjusted pacing profiles. So we then aggregated these into a number of weekly training features, which includes the number of active days run per week, the total weekly distance, the mean grade adjusted pace, the longest run distance, and the fastest 10K. And from there, we then wanted to get some 4-week features to get an understanding of how their training looked over the previous 4 weeks. So using the previous features that I described, we then took the average, standard deviation, and relative change. So for example, with total weekly distance, what's the average total weekly distance per week over the last 4 weeks? What's the standard deviation of the total weekly distance over the previous 4 weeks? And what's the average relative change? So the average week-on-week change for that feature over the previous 4 weeks. And we did this for all of those different features. So one challenge that we had with this project was that we don't have explicit injury labeled data. So we only have the raw activity data from the wearable sensors, and we don't have anything in there that had the runners labeling when they might have been injured or having to take a break from training for any reason. So what we have are training breaks, and that's what we've used as a proxy for injury. So we took any breaks greater than or equal to 14 days to be a proxy for injury. And the thought process there was that even though there could be a number of reasons why a runner might become injured or might take a break, it could be due to illness or a holiday or just being too busy at work, the thought was that 14-day break is a quite significant break to have in a 16-week training period before a marathon, and to still be able to complete the marathon with that type of break. So we felt that anyone taking such a long break was likely due to injury. So In terms of how the case representation is done, a positive injury case now denotes a runner who has experienced a 14-day training break after the given week of training. And it's also associated with two further features, which is the date of the training break and the length of the training break in days. The negative injury case then is still just the features of that week of training, but then with a prediction or with a label of healthy. And they don't have any further features since there hasn't been any such training break for them. Another issue that we had with this was that the case base contains a lot more non-injured runners than injured runners on a given training week. So this can be a really big issue because in the modelling, if there are big differences in the numbers of positive and negative cases, a model may just end up favouring the larger case. So just predicting everyone as being healthy because there's only a small proportion of injured runners. So we needed to balance the case base. So we did this using random undersampling. So selecting a random subset of negative cases to match the number of positive cases. And that meant that there would then be the same number of positive and negative cases in the case base. We did try another method, which was nearest unlike neighbours. However, we found that the random undersampling led to more accurate prediction results. So in terms of predicting injuries, we have two options. One is a one-shot prediction as healthy or injured. And then we also had a risk score, which was more of a likelihood of being injured, somewhere between 0 and 1. So the way that we did this then was for a given query runner, which you can see on the diagram in green, we wanted to find the nearest neighbours based on the sex of the runner and the training features. And once we have that, we would get the prediction as the highest label in the group of runners. So if there were more injured runners, then they would be predicted as injured. If there are more healthy runners, then they predicted as healthy. And then the risk score was the proportion of injured runners in the group of runners in the K nearest neighbours. Then we also wanted to provide some sort of explanation to go along with this prediction. So counterfactual explanations typically involve finding the closest cases that are in the more beneficial class. So here you wouldn't want to be predicted as injured, so we try and find the nearest runners that are in the healthy class and have some understanding of how a given runner would be comparing to those. And it's less really about justifying the prediction, but really to provide an understanding of why they might be at risk and how they might be able to reduce their risk in future by training more similarly to the healthier cases, to the counterfactual cases. So here we have what we've done to really get a sense of how the features compare between the injured and healthy classes for a given runner who's been predicted as injured. We would get the K nearest neighbours that are predicted as injured. So these would be the factual cases as they're sort of backing up the injury prediction for the given runner. And then we'd also find the K nearest neighbours that have been predicted as healthy. And these are counterfactual cases. And we then took the sets of factual and counterfactual cases and compared the feature differences amongst the two groups using t-tests. Then we were able to have a list of features for a given runner for which there was a significant difference between the counterfactual or the healthy cases and the factual/injured cases. So moving on to the evaluation, as I mentioned, our data set includes 5,000 unique runners who completed marathons between 2014 and 2017 with finish times between 2 and 6 hours. For each of the tasks, we used standard crossfold validation to really validate the results. So we split into a 20% test set and 80% training set 5 times, where at each time there'd be a different 20% used as testing and this different 80% used as training. And over the 5 folds, we averaged the prediction accuracy. So for evaluating the prediction score, for the prediction, we calculated the mean absolute error between the predicted class and the actual class of the test cases. And for the risk score, we looked at the correlation between the proportion of people with a given risk score and the actual proportion of people injured. So firstly, in our choice of K, for the mean absolute error, which we would ideally want to decrease, you can see that with the K increasing, with the number of runners increasing, we have a reducing mean absolute error. But then when we look at the risk score correlation, we ideally would have that risk score staying as high as possible. So in this case, when we have an increasing number of runners, the risk score starts to decrease. So there was a bit of a trade-off there. So what we decided to use was a value of 5 because that still had a reasonably low mean absolute error and similarly a high enough risk score. So looking at the mean absolute error of the predictions and the risk score correlation over different weeks, you can see that both the mean absolute error and the risk score correlation tend to improve as we get closer to race day, which is to be expected. And at the same time, we also looked at how the mean absolute error changes for the injured versus the healthy cases. And we found that the injured cases had a higher mean absolute error, meaning that it was easier for us to predict healthy rather than injured. Another thing to note is that the mean absolute error is definitely modest at best. You can see the value is around 0.4. However, we think that because there really isn't something available at the moment that allows runners to understand their injury risk, even being able to provide the risk score correlation, which is highly correlated with injuries, I think is beneficial for runners to be able to understand their risk score, given that there is nothing like this currently available. So in terms of evaluating the explanations, a live user study would really be required to understand the real impact of the explanations, whether the runners understood them, how they're used, and what effect they have. And so the things that we were looking at in our offline evaluation was really just to see, do the explanations make sense? And are they sort of including a good number of features for runners? So we wanted to see how often we were able to identify significant feature differences between the factual and counterfactual cases, what types of features were being significant, and what types of runners were most likely to be in the top 3 features recommended. So in terms of the number of features, we found that we could find at least one significant feature difference for 80% of cases. So that means for 20% of runners, we didn't find any significant feature difference between their factual and counterfactual cases. And on average, we had about 2.4 significant features per runner, which isn't too bad because we wouldn't like to have there be a case where we have multiple suggestions being made to the runner to change their training, because that would be quite a lot of things to have to change. In terms of the types of features, we found that the more load-based variables, so the active days and the total distance, were more commonly found in the top feature by mode and the top 3 features by t-value, compared to the more intensity-based features, which were fastest 10K and mean pace. So back to what we are trying to build here, this now allows us to be able to provide the runners with an understanding of what their injury risk is based on our injury correlation or injury risk coefficient and how that correlates with injury. So saying that your risk of injury is two times that of similar runners at this training stage. So that gives us a sense of how your injury risk is comparing to other runners that are currently at the same point in training. And then being able to tell them that runners similar to you who have become injured have a weekly distance that is 10% greater than the runners who likely avoid injury. So this is giving us the understanding of the comparison between the factual and counterfactual cases here. So understanding that the runners who do become injured, their total weekly distance is higher than runners like you who have become injured. That it's lower than runners who have become injured. So the idea here is to consider reducing the weekly distance from 60 kilometers to 54 kilometers per week. And that would hopefully be able to help them lower their score in the coming weeks. So to conclude, we were able to provide a novel case-based reasoning approach with some much needed injury support for marathon runners. We did have a difficulty of having the lack of labeled data, so using the training breaks as a proxy for injuries meant that we don't necessarily have a definitive evidence of injury. And a live user trial would really be needed to understand how the runners interact with the information, whether they actually make any changes to their training or not, and really to understand how they feel about those. And while we do feel that the results are modest in terms of the mean absolute error of the injury risks prediction, we did still get a really highly correlated injury risk score, which correlates highly with the actual risk of injury. And because there really aren't any such supports available for runners to understand what their risks might be and what they might be able to do about this, we still feel like this is a very, very useful case-based reasoning method that has been developed, and that will be very useful for marathon runners. Thank you so much for listening.
Well, thanks everyone so much for watching. I hope you find this interesting. I'd love to hear a bit about your research in the comments below, and I will see you all in the next video. But before that, I just wanted to say a huge thank you to all of my wonderful members. You really make it possible for me to keep making these videos, and I'm so, so grateful for you. Thanks so much everyone, and I'll see you in the next video.